Okay, so on page, what are we on? Page 176. Go ahead and think about the Explore right here. So think about question A and B, and then try to think which one you can do, and see if you can think of any math that would support your answer. So you might have some logic, so that's great too. Think logically why that would happen. But then we're also going to try to do a little math here to figure it out. So, and if for some reason you need formulas, you can look at the bottom of this page, and the next page there might be some formulas to help you out if you want to calculate a little bit of math. So I'm going to pause, think about them, and then we'll talk about these. All right, so let's look at these. So if you like thick brownies, then we're talking about area, like how much space it takes up. And then volume as far as going up, I guess. But when you pour the batter, it's area, and then as it cooks up, it's volume. But if you pour the batter into the square, and technically the round should fit in the square, but we know if the glass has some thickness, it's not going to, but in theory. So that batter is gonna rise more if it's in the round one. It would flatten out more if it's in the square one. So you get more area when you use the round one. Volume is going to be the same either way. It's just going to be spread out volume in the square, or, more up volume in the round. And so then calculation to support our answer. So we could look at area there. And if you look below area, the formula is base times height for a square or rectangle. So 8 times 8. And notice if I put the units in there, I can get my new unit. So I'm going to get a new answer of square inches. And a circle is pi r squared. And most of you have a pi key. If you don't use 3.14159, or a math lab, if they say 3.14, that's fine. But if it says use the pi key, use it. And then radius, so if this is 8 across, it's 8 across here too. So the radius, a ray like on an angle is half of it, like this is a ray. So a radius is part way, so that's 4 inches. So then 4 inches squared will give me pi 16, and I'm going to get square inches. So again, if I use 3.14159 or whatever, I'm going to get about 50.3 square inches. Now in my math lab, they might say, give your answer in parentheses with pi, so then it'd be like 16 pi square inches would be the exact answer. Okay, so sometimes in the parentheses it might say use the pi, so make sure you don't do a decimal then. All right, so obviously this has more area, this has less, so if I want my brownies to move up and not out, then I definitely want this one. Okay, second one is, and I didn't even realize people like the crispy edges, but there are people that like the crispy edges. I like gooey brownies, so if it were me, I would undercook them a little bit. But this is why someone made millions of dollars, because they came up with this simple thing, which again, entrepreneurs, but they created what we call a brownie pan, and it's all metal, so you get more edges, because if you want more perimeter, you just create little boxes and you get lots more. So you get crispy edges on every single brownie. But in this case, we want more perimeter. And so this guy is going to give us more perimeter. And again, if you want to look below for perimeter, they only give it for you the circle. Perimeter is just adding up all the sides, so you really don't need a formula. 8, 8, 8, 8. So what is that? I could just multiply instead of repeat adding, but you could add 8, 8, 8, 8. Doesn't matter. All right, so what is that? 32 inches. And you're not creating a new unit. You're just adding inches with inches with inches with inches, which just gives you more inches. And then for circle, we don't call it perimeter. We call it circumference. I always memorize it as clowns, like in a circus, get pied in the face. So then I can remember the formula. So then the other one, pi r squared, goes with area. So if I get clowns get pied in the face, diameter divides the whole thing across, which is 8 inches. And I'm going to erase this down here. So if I multiply pi times 8, and again, use this, or 3.14, depending on what my math lab tells you, I am going to get about, what? About 25 inches. And again, if my math lab says an exact answer using pi, you'd say 8 pi inches. And so if I compare these, this one has a perimeter of 32 inches if you go around the outside. Circle has 25. So if I want more crispy edges, I'm definitely going to go with the square pan. All right, why don't you pause it and then look at all the formulas on page 176 and 177, and then on problem number 2, try to figure out what all those variables stand for. Okay, so if you go and look at these, A stands for area, V is volume, let's see what else, length you probably know, width you know, base you know, radius, diameter, we just talked about those, and height. Now, so these two might kind of throw you for a loop. S, in elementary school and middle school, you're probably used to seeing SA. This is surface area. So like volume is like how much space a cube would hold, like if you filled it with water. Surface area is if like you wrapped it all in wrapping paper with no overlap, how much area would that paper take up? So this is probably one that might be hard. And then B, there's little b and big B. Little b stands for base, that's the bottom. But you see in the formula for a trapezoid, they have little b and big B. So the formula for a trapezoid is area equals half. And then most people use base 1 plus base 2 times the height. So most people would call that base 1, base 2. And then your height always has to be straight up and down at a right angle. So your base of a triangle, like if this is your base and your triangle, it has to hit at a right angle. So if you have a right triangle, this would be your base, that's your height. So they use little b for one of the bases, big B for the other base, but usually most of the time we use B1, B2. You might want to mark this page because you might need some of these formulas to do your homework. So, all right, pause there and let's see. We're going to go to the next page. All right, and so I'm going to pause quick and flip pages and we'll talk about the next one. Okay, so what I want you to do, I want you to pretend you're in class and we have some vocab here, so base and exponent. I want you to write these without any exponents. So like if someone gave you, 7 to the 5th power, you would just write it 7 times 7 times 7 times 7 times 7. Right, so these need to be written out all as factors. Don't multiply anything, don't do anything like that. And then next, rewrite them with exponents. So again, you can't multiply anything. You can write, so if I gave you this, you could write 7 to the 5th, but that's it. You can't multiply anything. Okay, so if I had 7 times 3, 7 times 3, 7 times 3, I could write 7 to the 3rd power and 3 to the 3rd power, but I couldn't write 21 to the 3rd power. No multiplying. And then I want you to try to figure out, a conjecture is like a hypothesis or an educated guess. Try to figure out what's going on here. So fill out the chart, pause it, do it on your own, don't cheat. Okay, you don't learn that way. So try it on your own, and then we'll come back. Okay, so all I did is I wrote what these things mean. So 3 times 5 squared means that you have 2 sets of 3 times 5. 2/3 squared means you have 2 sets of 2/3. 7 to the 3rd squared means you have 7 times 7 times 7, but twice. And then 11 to the 5th would be 11 times 11, 5 times, 11 squared, 11 times 11. All right, so now we're going to rewrite these. So if we come over here, I have 2 3s, so that'd be 3 squared times, and then I have 2 5s, so 5 squared. And again, I'm not going to do any math. I'm just writing these with exponents. So over here, I can't do any math. So I'm tempted to do, 4, but I can't do any math, so 2 squared. And again, I'm tempted to put 9, but I can't do any math, so 3 squared. And here, I am not tempted because I have no idea what 7 times 7 times 7 is, but I know that that would be 7 to the 6th power. And this last one, I do not want to multiply all those 11s and divide. But I do know that with fractions, if you have something on top and bottom, when you divide, you get 1. So I know I can cancel those or simplify. So I'm going to cancel. Then I know I get 3 11. And again, I don't know what that is, but I'm going to write 11 to the 3rd power. All right, so now I need to kind of look at what's going on. So it looks like I can kind of have 2 sets of 3 and 2 sets of 5 there. Here it looks like I have to do this to the numerator and the denominator, so 2 squared and 3 squared if I look over here. Here it looks like when I have a power to a power, I end up multiplying those and getting 6. And our division, it looks like I cancel, so it looks like I'm going to subtract my exponents. All right, and so if we look at one other pattern that is on the next bottom of the same page, it has powers of 4. And so I'm going to do a different number, but say you have 2 to the 4th, that's 16. 2 cubed is 8. 2 squared is 4. 2 to the 1st is 2. So the pattern as I go down is divide by 2. So 2 divided by 2 must be 1. So 2 to the 0 power has to be 1. And technically, if I keep going, negative exponents, well, you can't have negative numbers here because what's your pattern? Divide by 2, divide by 2, divide by 2, divide by 2. So this is going to become 1/2. and 2 to the negative second is going to become 1/4. So negative exponents don't mean you owe something, it's reciprocal. So you can kind of see how those flip. So 2 to the negative third is going to be 1/8. Now, if some of you are like, well, you know, does that pattern always work? Okay, well, different numbers, but the idea is the same. So like say I give you, I don't know, like 3 to the 4th is 81, 3 cubed is 27, 3 squared is 9, 3 to the 1st is 3. So as I go down a power, I keep dividing by 3 over and over again. So again, 3 to the 0, 3 divided by 3 is 1. So anything to 0 power is 1. And again, if I do negative exponents, it just means flip it. So like 1/3, 1/9, 1/27, 1/81. So negative exponents don't mean you owe any money. It just means to reciprocate or to flip. All right, go ahead and look at the rules on page 179 and read all of those through, and then we'll do some math here. Okay, there's a really boring YouTube video that was out, and I always thought I could find it, but I can't anymore. But the guy was always like, if in doubt, write it out. So he was kind of like Eeyore type voice, and it was a terrible video, but I love that saying. So if in doubt, write it out. You need to do that. So if you have something like, let me try to find a pen here. There we go. So if I have x cubed times x to the, I don't know, 8th or something like that. I don't want you to guess like, oh, I need to multiply those. Oh, I need to add. I don't want you to guess. So, and I also really don't want you to memorize. So write it out. This is x times x times x, because that's what x cubes means. This is x times x times x times x, 8 times, right? And so how many times am I multiplying x? Well, 11 times, because when you're multiplying, you're writing all these factors and you're just counting them. And counting in math is adding. Now again, when I taught 8th grade, I did come up with a mnemonic device to help with this, but I'd rather you not memorize. So it's ma, which means when you're multiplying exponents, you can add them. All right. But again, if in doubt, write it out. It's not worth missing on a test because these are worth a lot of points. All right. Say I give you x cubed, to the 2nd power. Okay, if in doubt, write it out. So x cubed, and this means I have 2 sets of this, or 2 groups of this. Okay, so if I have 2 sets of it, I have this. And so again, if I count them, I have x to the 6. Now again, why did I multiply here and add? Here I'm counting, which is adding. Here I have 2 groups of 3, and in math, when you do groups, you are multiplying. Okay, so think about like, oh, I don't know, like if you have 3 dots and another 3 dots, and I'm 2, I give you x cubed and x to the 3rd, these are all x's, then you're just counting the dots. But if I give you x cubed to the 3rd power, that means you have 3 sets of 3, so 3 groups of 3, and 3 times 3 is 9, so you're multiplying. Now, my little mnemonic device for this is when you have a power to power, you multiply, so PM like post meridian. So when you have a power to a power, you multiply. But again, you can always write it out. And the other main one is if you have something like x to the 6th over x squared. Again, if in doubt, write it out. So you have 6 x's, you have 2 x's, and you know that you can cancel or simplify. So how many x's are left? X to the 4th. Okay. Now again, what's my mnemonic for this? Well, we're dividing. So it was like a Nintendo DS. And so a Nintendo DS. So D stands for divide, S stands for subtract. And the reason you subtract is because you're canceling some things. All right, so what I want you to do is on the top of page number 180, I want you to try all of the problems on number 4 and see how they go.